So this is the first testing video of the Ohmega Switch in a high power application. Still in testing / prototyping, but as you can see here, got a little bit of a temporary plate on there, but Ohmega Switch, you have daily, off, and burp positions. Basically, the goal of this device is to switch the nominal impedance of your system, say from 1 ohm daily to 1/4 ohm burp, with just the turn of a switch instead of having to rewire. So we're going to be testing how it likes high power today. As you can see here in this green bucket, I have 2 coils submerged in concrete, and they are bifilar wound, so there should be very minimal rise on them, if you will. But yeah, 2 1 ohm coils. This first test will be 2 ohms. So as you can see here, we're actually hooked up to the mains right now, which I don't suggest doing unless you feel very confident in what you're doing, simply put. So I'll go ahead and put this on the meters now. And I'm gonna take a reading about 2 seconds in. Sorry, I'm getting over a cold. That way it kind of gives it a chance to level out. So I'll capture the voltage and amperage on my phone, and then this multimeter actually measures the drop over the 2 terminals on the switch, so you know how much power you're losing to the switch. So let me go ahead and kick this on, and then after 2 seconds, go ahead and take our readings. So, bring the phone up closer. 120.9 and 54.1. And that totals out to be 6,540 watts. And that's, the power factor should be at 100% with how the coils are wound. So then, if we take our drop across the switch, which is 0.066 times our amperage, 54.1 times 2, since it runs through the switch twice, you can see 7.1 watts were lost through the switch, which really isn't bad for how much power we're putting through it. So let me go and reset this, and we'll test it with a little bit more power. So round 2 on the Ohmega Switch. As you can see, since I have 2 1 ohm coils hooked up, I only have 1 coil hooked up right now, so we'll have a 1 ohm load, which should give us about pretty equal amperage and voltage. So let's go ahead and test this out. Again, it's live, hooked up to the wall, so after about 2 seconds I'll go ahead and capture our readings and see what we get. So, go ahead and show you this. 118.8, 95.7. Not quite 1 ohm, but as the heat goes up, the resistance will go up as well. So, can't really get it much better than that, and that's plenty for what I'm testing for. So, 11,369 watts. And then our voltage across the switch was 0.089. So we'll do that times our amperage, 95.7 times 2 since it runs through twice, and you're looking at 17 watts lost through the switch. still not bad. And I'll go ahead and reset this one more time. Camera's wigging out one more time and see how she likes real power. So this is round 3 of the Ohmega Switch testing. This will be both the coils in parallel, which will be about a 0.5 ohm load. Really see some high power on this, and this will actually be slightly over the highest warrantyable power for the switch, because it's going to be up to 20,000 watts rated is what this switch will be good for, and I'll be running a little bit over that. So let's go ahead and get the testing underway. Like I said, the other 2 tests, give it about 2 seconds to settle out, take our readings, and do the math. So, if you take a look at the phone, 115, 177.6. That comes out to 20,424. Man, pretty sure the coils are getting pretty warm at this point, considering my 8-gauge lead wires are getting warm. And then, let's see, our drop was 0.073 times our amperage, 177.6, and then times 2 gives you 25 watts lost through the switch. So really not too bad, especially when you're putting out 20,000 watts. And that's all for testing.